Hi, I'm following Paul McWhorter's Arduino Uno R4 Wi-Fi lessons, and I'm currently on lesson number 3 when he wants us to blink 4 LEDs simultaneously. You can see them there. Now I just want to say that recently the comments with the links to my solutions that I'm leaving on Paul's videos have been disappearing. Thanks YouTube. So maybe you might consider subscribing and getting notifications, otherwise you might miss something. I've only just started using the Arduino and C++, but hopefully my skills will improve and you might find something you're interested in. Right, here's my setup. I'm using a projects board, but I can still plug things in there if I want a breadboard. So I'm using a ground there, and then I'm using pins 8, 9, 10 and 11, which come round. Now that's 8, 9, 10, 11, and it goes to my 4 LEDs, and then my LEDs go to my network resistor, and then the ground comes out that end. All very simple, but it means that it just stops having to have all those stupid loopy wires that I hate. Anything else to say about no, nothing really to say about the board. So here's my program. Now my first program is very basic. I deliberately made it as simple as possible. So all I'm doing is I'm setting the pin mode on 8, 9, 10, 11, then I'm setting it high, delaying, setting it low, and I could have put that in a loop, or could have put that in a loop, I could have done all sorts of things, but this is how a really, learner would do it. So I will plug it in. It will still be flashing from last time, so ignore that. And I don't know if you can see that pink. I'm using pink LEDs, especially for Laurie and Wendy, because girlies ought to stick together with pink. So I will upload this, compiling, and there you can see it's flashing. Nothing too exciting about that, but I thought there must be a better way of doing this, because that really is rather pathetic. So I heard about something called direct port manipulation, and as you'll see, it uses less code, and it's faster. Well, you can't tell that it's faster, but I can tell you it is faster, and it does everything simultaneously. So right, if we have a look at an Arduino, which way around is it? Right, there. The Arduino has 3 ports. You've got port B, which is pins 8 to 13, which are those. And then you have port C, which is A0 to A5, and port D are pins 0 to 7. And it means that using direct port manipulation, you can control all of the pins in a particular port at one time. I'll show you what I mean, because it's too difficult to explain, but it's too difficult for me to explain anyway. Right, we will look at my next program, which hopefully does the same thing. Now, with the first thing you do is for a port, you have the data direction register for port B, which is DDRB, and you set it to that, and that each of those zeros and ones is it applies to the pins within that port. So going from the right, that's 8, 9, stop doing that, you horrible thing, 8, 9, 10, 11, 12 and 13. And if you set it to 1, it's output, and if you set it to 0, it's input. So that statement there is just setting pins 8, 9, 10, 11 to output. Then we come down here, and port B is when you set the pins to high or low, and it's exactly the same. So you've got, stop doing that, 8, 9, 10, 11 are all set to high and the others are set low. And then you delay for 20 milliseconds and then you set them all to low, and then you delay and go round and round and round. So hopefully this will do the same thing. And yes, it's doing the same thing. But there's a problem with this, because if you're actually using 11 and 12, no, 12 and 13 there, you're setting them to input, and you really want to leave them alone. So I've got something down here. Take that line. You're doing exactly the same thing, only you're doing a logical OR with it. And if you do a logical OR with a 1 in each position, that sets it to 1, whatever it was. But if you do a logical OR, it leaves the pin to what it was. So that means that that statement says set 8, 9, 10 and 11 to output, and then leave the rest as they are. So all I had to do there was put an OR, and exactly the same principle goes with setting them high. Now setting them low, here I just set them all off, which isn't what we want to do at all. So down here, if you do a logical AND, that means that for pins 8, 9, 10 and 11, you're turning them off, and a logical AND with a 1 means you leave it as it was. So I will copy that and put that in my program. Now just check. Now that is 8, 9, 10, 11. Yep, that's 8, 9, 10. And that ought to work. So we will upload that. And it's working. Great. And the beauty of doing it in binary is you can see just from that string, binary string, visually what the state of the pins are and whether they're input and output and everything. But if you want, you can do the same thing and just do it. You can do it in hex. Now I've got little, that's your F. So you could actually change that line to use hex, which is can't remember if that was right. Yeah. And you can change that line, and you can mix and match. You can use hex up there and binary down there, whatever, but we'll put them all in as hex to see whether it works. F, and then that one go down to my notes. That is 30. And hopefully that will work. Oops. No, it won't work. What have I done wrong? Is that better? Yeah, that's better. Right, try again. And yep, it's still working. And you can even do it in binary. You can just change that to 15, and that's 15, and then that would be 48. And well, just prove it does still work. Did I say binary? Decimal. That's decimal. Look, that number, those 3 numbers are decimal. It still works. Anyway, that's my idea for simplifying everything, and I've got a sneaky suspicion that it might come in useful for Paul's lesson 6, which is creating a binary counter. But